All right, today we're going to be covering 2.11 congruent angles associated with parallel lines. So go ahead and pause the video, try out this proof to get started, then we'll be going through it together. All right, so getting started on this, we have given angle 1 and angle 3 are supplementary angles, meaning they'll add to be 180 degrees. We want to prove that line M is parallel to line N. So to get started, our first reason should be given, because they tell us angle 1 and angle 3 are supplementary. That is a given statement. So we can just write given N. From here, angle 1 plus angle 3 is equal to 180 degrees. The reason that we can say this is because if two angles are supplementary, again, I'm taking that from my previous statement, then their sum is 180 degrees, taken from my current statement. So if two angles are supplementary, then we know their sum is 180 degrees. From there, we can say angle 2 is congruent to angle 3. Because if we look at our diagram, angle 2 and angle 3 are vertical angles. And we know all vertical angles will always be congruent. So therefore, angle 2 and angle 3 are the same angle. They're the same measurement. So if they're vertical angles and they're congruent, I can say angle 2 is equal to angle 3. Because if two angles are congruent, then they have the same measure, then they are equal. Well, if angle 2 and angle 3 are the same, then I can just replace angle 3 with angle 2. So now instead of measure of angle 1 plus the measure of angle 3 equals 180 degrees, I now have the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. And I did that just because I substituted the measure of angle 2 in for the measure of angle 3. From here, if two angles' sum is 180 degrees, then I can say that they are supplementary. So angle 1 and angle 2 are supplementary because if two angles' sum is 180 degrees, taken from my previous statement, then they are supplementary angles, taken from my current statement. Lastly, if angle 1 and angle 2 are supplementary, well, their angle relationship is that they are same-side interior angles. And if same-side interior angles are supplementary, that implies parallel lines. So therefore, same-side interior angles supplementary implies line M is parallel to line N, which is exactly what we're trying to prove. So at this point, this proof is now finished. All right, so moving on. Again, today we are covering 2.11 congruent angles associated with parallel lines. Our learning target: I can solve problems involving all angle relationship theorems created from two parallel lines and a transversal, meaning alternate interior, alternate exterior, same side interior, same side exterior, corresponding angles, and vertical angles. So we have quite a few of them that we're going to be going through today. But again, a lot of this should be review as we've covered this in the past. Today we're just creating our shortcuts. So with that being said, we're going to go ahead and start with one of the most important geometry theorems. And this theorem, well, it's not really a theorem, it is a postulate. This postulate has changed geometry drastically in the last 200, 300 years. So this postulate is the parallel postulate. It states, through a point not on the line, such as point P, there's exactly one line that will go through point P and be parallel to line A. And that line, I went ahead and drew it, is line B, because again, if they have the same slope, they're parallel. If it's going through this one specific point, it needs to go through that point and still maintain that same slope. So there's only one line that goes through this point and remains parallel to the other line. Now, the reason why this is so important is because a couple hundred years ago, maybe not even that far back, there were a couple mathematicians who said, what if the parallel postulate isn't true? And just so you know, the parallel postulate's been around for thousands of years. It's been around since Euclid compiled all of the geometry theorems that we've known, that we've discovered throughout the ages, and put into one textbook, Euclid's Elements. When he created that, the parallel postulate was the fifth postulate in that book. It was one of our assumptions. It's one of the things that we can assume to be true, and when we assumed it to be true, it helped geometry fall into place. However, a couple hundred years ago, a couple of mathematicians said, what if it isn't true? What if there is a line that crosses through a point and is parallel to the other line, but they still intersect? And we actually have real-life examples of these lines. They actually exist in our world. And when they came up with this idea, unproving the parallel postulate, when they said, okay, what if this isn't true? They created a whole new form of geometry. That form of geometry is called non-Euclidean geometry, and it operates based upon spheres, based upon circles. So the most easy example that we can actually see of this happening in real life is on our globe. On our globe, we have both lines of latitude and longitude. So we know that our globe looks like this, where it just circles around, right? We have these latitude and longitude lines, and then it also goes up and down. So we know that these lines are all around the globe here. Now, all these lines are parallel, meaning they'll never touch each other as you travel along the globe. If I travel along this line here, I'll never touch another one of these lines if I'm traveling along it. However, they also intersect at both the North Pole, they all cross at the top, and they all cross at the very bottom, the South Pole. So these lines are showing that they are parallel, but they also intersect. So in fact, these are showing that the parallel postulate isn't necessarily true. However, if we're looking at Euclidean geometry, which is what this class is all about, this is the only geometry that we'll learn in here, is Euclid's geometry, then we're going to assume that this is true always. However, I want you guys to know that there is geometry out there, and it's fairly new compared to Euclid. Euclid was thousands of years ago. This is only tops a couple hundred years old. This whole new idea really changed geometry for the better. It created a whole new section, a whole new form of mathematics, and it's something else that we can use to perceive the world around us. So just know that this is out here, but know that the parallel postulate just says that if I have a point that is not on a line, there's only one line that goes through that point, making both lines parallel to each other. So just keep that knowledge with you, that the parallel postulate exists. It's the only postulate that we'll use that we say, oh yeah, this is true. But know that down the road, if you choose to go into mathematics or specifically geometry down the road, you'll learn more about non-Euclidean geometry and how that relates to the world around us. All right, so next up, our next theorem is if two parallel lines are cut by a transversal, and that's how many of these proofs will start today, then any pair of the angles formed are either congruent or supplementary. There's no difference. It's either going to be congruent or supplementary. No other choices. So again, we know vertical angles are congruent. Vertical angles are congruent. Alternate interior angles are congruent, which means vertical angles are congruent again. Likewise, alternate interior angles are congruent, and vertical angles are congruent again. So anytime that you're given one angle with two parallel lines and a transversal going through, you should be able to find every other single angle. For instance, if this is 30 degrees, I know the opposite side is 30. I know that this would be 30 and this would be 30. And that leaves the other angles as 150 degrees because they'll be supplementary. So therefore, they're either congruent or supplementary. You should be able to find every single angle given one of them. And again, I just chose 30 as an example. We were able to find every other single angle based upon just that. So again, very useful information to know that if we have two parallel lines and a transversal cutting it, they'll either be supplementary, if they say same side anywhere in there, or if they're straight angles, they're supplementary, or they'll be congruent, such as vertical angles, anything alternate interior or exterior, as well as corresponding angles. So again, corresponding angles are the only angles that are on the same side of the transversal, but are also congruent. So again, we'll be using this theorem pretty consistently. It is just knowing the angle relationships as well. For instance, if, like I said, this is 30 degrees earlier, I couldn't say that this angle is 30 degrees without noting that they are alternate interior angles. So we're going to be using a lot of those theorems that we've been talking about in order to prove that the lines are parallel. All right, so this proof you don't actually need to write up. In fact, there's going to be a couple proofs throughout today's lesson that you guys don't need to write because they are pretty straightforward. They're just talking about these shortcuts that we've been using. And now they're allowing us to say that these shortcuts are true, so we can use them anytime that we'd like. The first theorem says if we have two parallel lines that are cut by a transversal, each pair of interior angles on the same side of the transversal are supplementary. All they're trying to say is that if we're given parallel lines, then same side interior angles are supplementary. They're just giving us a new shortcut for this. So again, we don't need to prove it, but this is the proof. It's just 2 steps, because again, it's our shortcut. So if number 1, A is parallel to B is given, so angle 3 is supplementary to angle 5, because 2 lines are parallel implies same side interior angles are congruent. So again, that's how many of these shortcuts will be today. I don't expect you guys to write out the theorem, because you guys should know these already. If you don't know them, then feel free to write it out. And I'm not going to have you guys do the proof, because again, it's just going to be a 2-step proof for a shortcut. So just know that these angle relationships are the shortcuts we can use in our proofs. Now, in order to prove all angle theorems, there are certain ways to do this, because we know that vertical angles are congruent, we know alternate interior angles are congruent, and we know straight angles equal 180 degrees. Just with this information alone, we can find every single angle within 2 parallel lines and a transversal, within these angle relationships. So the first thing that we do is we start with angle x degrees. We don't know how many degrees it is, it's just a random number. So we start with our initial degree here, x degrees. Now, from here, I know that if they're on opposite sides of an intersection, they're vertical angles. So both of these angles are x degrees, because vertical angles are congruent. Now, the supplement to an angle of x degrees would be 180 minus x. So if I have a linear pair, a pair of angles that form a straight line, those angles are supplementary. So the supplement to angle x is 180 minus x. The reason for that is because x plus 180 minus x, these should be supplementary, meaning they add to be 180. Well, the x and the negative x cancel, and we get 180 equals 180. So this is a true statement, which means that 180 minus x is indeed our supplement. So therefore, I can draw 180 minus x as the supplement for both linear pairs. Again, this is a linear pair, this is a linear pair. So you can draw those because straight angles equal 180 degrees. Next up, the other theorem that we mentioned was alternate interior angles being congruent. So if this is x degrees, the alternate interior angle to this is right down here. So this will also be x degrees. Similarly, if this is 180 degrees minus x degrees, down here will be the same. So we can draw those alternate interior angles that are congruent, and then we can finish off by knowing that vertical angles are congruent again. So this angle will be x, this angle will be 180 minus x. So again, you'll be able to use these anytime, but those 3, vertical angles, alternate interior angles being congruent, and straight angles equaling 180 degrees, those will be the main things that you use as you prove these proofs about angle relationships. So using those, you can solve for any angle relationship and prove it. Next up, these next couple theorems you guys do not need to write, because again, these are just going to be the shortcuts. So our first shortcut says, if 2 parallel lines are cut by a transversal, each pair of alternate exterior angles are congruent. Meaning parallel lines implies alternate exterior angles are congruent. So again, that's just our shortcut now. So we can use that all the time. If you see parallel lines, you can automatically assume that alternate exterior angles will be congruent to each other. Likewise, if you see parallel lines from now on, you can know that corresponding angles will also be congruent. We can see that in that diagram 5 that we did a couple slides back. If you looked at any of the corresponding angles, they are all congruent to each other. Next up, if we have parallel lines, then alternate interior angles are also congruent. Again, this is just another shortcut for us. If you see alternate interior angles and you already know that the lines are parallel, you can automatically assume that they're going to be congruent to each other. That's another shortcut that you can use. And then the last shortcut that we're going to talk about is same side exterior angles. If you have parallel lines, meaning A is parallel to B, then same side exterior angles will be supplementary. and that will always be the case. All right, next up, we have a theorem that I would like you guys to write down. This is the transitive property of parallel lines. It says, if two lines are parallel to a third line, then they are parallel to each other. And in fact, we'll use this one later on today. So, given that A is parallel to B, and B is parallel to C, well then A will be parallel to C. So this is just the transitive property of parallel lines. If two lines are parallel to each other, and one of them is parallel to another line, then all three are parallel to each other. The other theorem that I'd like you guys to write down is this next theorem. In a plane, if a line is perpendicular to one of two parallel lines, it is perpendicular to the other. So, if A is parallel to B, and C is perpendicular to A, then C will be perpendicular to B. Now, as a proof for this, I went ahead and drew some points. So I drew point A, B, and C on lines C and A. And I drew points D, E, and F on lines C and B, which led me to this proof. So, statement 1, A is parallel to B, that is given. C is perpendicular to A, that is also given. From here, I can say that angle ABC is equal to 90 degrees, because if two lines are perpendicular, then they intersect each other at 90 degrees. From here, I can say that angle ABC is congruent to angle DEF, because if we have parallel lines, corresponding angles will be congruent. That's one of those shortcuts that we just covered. Lastly, I can say that C is perpendicular to B, because if DEF is congruent to ABC, then angle DEF is equal to 90 degrees. Therefore, C is perpendicular to B because line C intersects line B at 90 degrees at a right angle. So therefore, if I have two parallel lines and our transversal is perpendicular to one of those lines, it'll be perpendicular to the other as well. All right, next up, let's go ahead and move on into some practice for today. So here's our first practice problem. If C is parallel to D, find the measure of angle 1. Feel free to pause this video if you'd like. I'm going to go ahead and start working on it though, and for all the rest of these videos or any of these problems, feel free to pause at any time and try them out on your own first. So first off, looking at 3x plus 5 and 2x plus 10, their relationship is that they are alternate interior angles. And I know alternate interior angles are congruent. So I can go ahead and say that 3x plus 5 is equal to 2x plus 10. Because congruent means the same, and if they're the same, they're equal to each other. From here, I can go ahead and solve for x. So if I subtract 2x from both sides, I get x plus 5 equals 10. From here, I subtract 5 from both sides, and I get x is equal to 5. Now, the relationship between this angle here, 3x plus 5, and angle 1 is that they are vertical angles. And I know vertical angles are always congruent to each other. Likewise, angle 1 and 2x plus 10 are corresponding angles, and corresponding angles are also always congruent to each other. So therefore, I just need to plug 5 in for x for either of these two equations. It does not matter which one you choose, because again, they're the same angle. They're equal to each other. So I can say the measure of angle 1 is equal to 3 times 5 plus 5. That'll give me 15 plus 5, or 20 degrees as our answer. So x is equal to 5, and the measure of angle 1 is equal to 20 degrees. All right, next up, we have a proof. Go ahead and pause the video and try out this proof if you'd like, and then we'll be going through it together. All right, so first up on this proof, we know that G is parallel to H. That's given to us, so that's what we can start with. From here, if I look at angle 2 and angle 3, they form a straight angle. So therefore, these two angles are supplementary. So I can say angle 2 plus angle 3 is equal to 180 degrees. If two angles create a straight line, then their sum is 180 degrees. Definition of a linear pair. Now, let's look at the relationship between angle 1 and angle 3. I can look at angle 1 and angle 2, but there's no relationship between these two angles. We don't have a relationship that we know for these. However, angle 1 and angle 3 do have a relationship. They are alternate exterior angles. So if I have parallel lines, which is given to us, then we know that alternate exterior angles are congruent. So I can say angle 1 is congruent to angle 3, because if G is parallel to H, then alternate exterior angles are congruent. From here, well, angle 1 and angle 3 are the same, so I'm just going to replace angle 3 with angle 1. So I can now say angle 2 plus angle 1 equals 180 degrees. And that's just by substitution. I just substituted in angle 1 for angle 3. Now at this point, if angle 2 plus angle 1 equals 180 degrees, then angle 1 and angle 2 are supplementary angles. Because if two angles sum is 180 degrees, then they are supplementary. And with that, this proof is now complete. Next up, we have our crook problem. Now this will be a bonus question for you guys, so I highly encourage you guys to try this one out. Make sure that you learn it, make sure that you know it, make sure that you're comfortable with it. If you're not sure, make sure that you ask, because you guys will see this one down the road. It will be worth an additional couple bonus points on the test if you choose to do it. If you don't choose to do it, it won't harm your grade. So this is a crook problem, and we're going to go through a couple of these. So the first thing that we do with a crook is we need to draw an auxiliary line. Now if you don't recall, an auxiliary line is a line you can draw to help in your proof. You get to draw it. Now, we're going to be using a theorem that we learned earlier today. We're going to use this theorem from earlier, the transitive property of parallel lines. So I know that A is parallel to B. What I want to do is I want to draw a third line that is parallel to both A and B. So our next line will be parallel to both. So I'm going to draw it, and when you draw your next parallel line, it needs to go through the bend in the crook. So it needs to go perfectly through this bend. So here is our parallel line. Now if there's multiple bends, let's say that we have like 2 bends, then I would draw 2 parallel lines. There's 3 bends, 3 parallel lines, so on and so forth. So depending on how many bends in your line there is, depends on how many auxiliary lines you draw. So now that we have our auxiliary line, that created 2 transversal lines for us. So I have this transversal line dashed in red, and I have this other transversal line dashed in red. So now that we have our 2 transversal lines, what we want to do is identify angle relationships to find pieces of angle 1. So I'm going to find the bottom piece, I'm going to find the top piece, and then I'll combine them together. So looking at the bottom piece of angle 1, what is the angle relationship between this 40 degrees and this bottom piece of angle 1? Well, they're alternate interior angles, and I know alternate interior angles are congruent, so this bottom piece of angle 1 is 40 degrees. So if this is 40 degrees, alternate interior angles are congruent, so therefore this is 40 degrees. Next, we'll focus on the top piece of angle 1. I know that this is 100 degrees up top. What is the relationship between 100 degrees and the top piece of angle 1 here? Well, they are same side interior angles. And if we have parallel lines, which we do, same side interior angles are supplementary, meaning they add to be 180 degrees. Well, if this is 100 degrees already, that means the top part of angle 1 will be equal to 80 degrees. This missing angle is equal to 80 degrees. So therefore, angle 1 is the total angle of 40 plus 80. So the measure of angle 1 is equal to 120 degrees total. So again, that's how you'll go through these crook problems, is first draw an auxiliary line through the crook parallel to your 2 given lines. It's important that your auxiliary line goes through the bend, so it needs to go through the bend. And if there's multiple bends, you draw multiple lines. Step 2, look for angle relationships to find these missing pieces. You won't always get a piece of the angle that you're trying to find right away. You may need to find some missing angles first. Then lastly, step 3, add up those pieces to find the total. All right, let's go ahead and move to a challenge problem with this. Do your best, pause the video and try this one out. We'll be going through it as soon as you're done with it. All right, so for this first one, the first step is to draw some auxiliary lines. And as we can see, we have one bend right here and another bend right here. So I'm going to draw two auxiliary lines. There's no other bends here. You may be like, well, isn't this a bend? There's already a parallel line. Isn't this a bend? Already a parallel line. So again, I'm just drawing two parallel lines that go through the bends within our crook. Now, once we draw those bends, we can go ahead and start moving towards solving this. So the next step is to look for angle relationships. So if I look at these two angles here, I notice that this bottom angle is 20 degrees. I need to find this top angle. So the angle relationship between these two angles is that they are alternate interior angles. And alternate interior angles are congruent. So if this is 20 degrees down below, this will be 20 degrees up top. So that first part, this first bottom half is 20 degrees. Next, let's go ahead and focus on the top because I can't find this top piece without working towards it. So I see that we have 100 degrees once again, and I have this 90-degree angle here. But this 90-degree angle is being split by this parallel line. So this top piece isn't 90 and this bottom piece isn't 90, but the full thing is. So I know that the relationship between 100 degrees and the top piece of this is that they're supplementary. So if this is 100 degrees, this top piece should be 80 because their sum is 180 degrees. So this top piece will be 80, which I drew in green because same side interior angles are supplementary, which leaves this bottom piece as 10 degrees because again, it's a right angle. If I've already used 80, that leaves 10 remaining here. So I just did angle subtraction. Now, looking at the relationship between the top part of angle X and this 10 degrees, well, these angles are alternate interior angles. And I know alternate interior angles are congruent. Therefore, the top piece is 10 degrees, which means the total of angle X is equal to 20 degrees plus 10 degrees, which is 30 degrees total. So our answer for this problem is 30 degrees. Now again, you're probably going to see something pretty similar to this down the road, so keep in mind that this will be the best way for you guys to study this bonus question, is looking back through these. Just as a recap, first thing that you do is draw your auxiliary lines through any bends in your crook. The second step, look for angle relationships. Find those angle relationships and work towards finding that whole missing angle. Once you find the pieces of that angle, add them together to get the total angle, and that will be your final answer. All right, with those challenge problems done, the rest of this video will be whiteboard review. So go ahead and try out these next couple problems on your own, and then I'll show you the answer afterwards. But this is just going to be review. Try and state the theorems that you're using in order to prove that these are true as well, because that will help with your mastery of knowing exactly what angle relationships are supplementary and what angle relationships are congruent. So here's our first problem. Find the measure of angle 1. You can pause the video if you'd like to try this one out, and then I'll be posting the answer shortly for you. All right, so for this one, we know that we have 133 degrees for the measure of angle 1. Or sorry, not for the measure of angle 1, for this angle right over here. We want to find the measure of angle 1, and I see that they are both parallel to each other. So the relationship between these two angles is that they are same side interior angles. And we know same side interior angles are supplementary. So 133 degrees plus the measure of angle 1 is equal to 180 degrees. Therefore, the measure of angle 1 is equal to 47 degrees. If we have parallel lines, that implies same side interior angles are supplementary. Next up, we want to find the measure of angle ABC. So go ahead and pause the video if you'd like. Try this one out on your own. There are multiple ways to do it, and then we'll try it together. All right, so for this one, I know that we have 83 degrees down here. And there is no angle relationship between 83 degrees down here and angle X. However, I know that this angle on the other side will be equal to 83 degrees as well, because vertical angles are congruent. Now, the relationship between this angle, 83 degrees that we just found in red, and angle X is that they are same-side interior angles. And I know same-side interior angles are supplementary. Anything same side is. So therefore, I can say 83 degrees plus X degrees equals 180. So X is equal to 97 degrees, which means the measure of angle ABC, which is angle X, is equal to 97 degrees. Next up, find the measure of angle DEF. Feel free to pause the video if you'd like, and then we'll work on it together. All right, so looking at these two angles, we have 8x minus 34 degrees, and we have 5x plus 2 degrees. Now these two angles, these are alternate interior angles. If we have parallel lines, that means alternate interior angles are congruent. So we can do 8x minus 34 equals 5x plus 2. Solving for x, we get 3x equals 36, so x is equal to 12. Now that we know what x is, we can go ahead and plug it in for the measure of angle DEF. So DEF is this angle right down here. Could I plug it in for either one? Absolutely, because they're congruent, and congruent means the same. So the measure of angle DEF, I'm going to plug it into the one with easier numbers to deal with, is equal to 5 times 12 plus 2. That'll give me 60 plus 2, which is equal to 62 degrees. So that is our final answer here. The measure of angle DEF is equal to 62 degrees. All right, next up, we're going to have a proof. Go ahead and fill in the missing statements and the missing reasons. Okay, let's go ahead and start working through this together. Given that P is parallel to Q, we want to prove that the measure of angle 1 plus the measure of angle 3 equals 180 degrees. So first off, my first statement is that P is parallel to Q. That is given. The second statement is blank, but they tell me the reason is the linear pair theorem. So do I see a pair of angles that form a straight line? Well, yes. Angle 2 and angle 3 are a pair of angles that form a straight line, and they're right next to each other. So that deals with the linear pair theorem. So I can say angle 2 plus angle 3 equals 180 degrees. That's the linear pair theorem. So 2 and angle 3 is equal to 180 degrees. Sorry about that. Let me just bring it up. From here, angle 1 is congruent to angle 2. Well, looking at these two angles, they're corresponding angles. Now, we already know that P is parallel to Q, so if we have parallel lines, which we do, that implies that corresponding angles are congruent, which they are. So we can say that angle 1 is congruent to angle 2. Next, we have a blank statement, but our reason is definition of congruent angles. So if I know that two angles are congruent, that means that they are equal to each other. So I can say that angle 1 is equal to angle 2 because that's the definition of congruent angles. Lastly, I'm going to go ahead and replace angle 2 with angle 1. That will give me the measure of angle 1 plus the measure of angle 3 is equal to 180 degrees, and that's by substitution. So I just substituted in, and again, that's what we're trying to prove. Angle 1 plus the measure of angle 3 is equal to 180 degrees. Which just shows us that same-side exterior angles are indeed supplementary. So with that, this proof is complete. Next up, go ahead and try this one out on your own. You can pause the video if you'd like. It says ocean waves move in parallel lines towards the shore. So we have these parallel lines of ocean waves, and they're moving towards the shore. The figure shows sandy beaches windsurfing across several waves. For this problem, think of Sandy's wake as a line. So here's her wake, and then we have these waves here, and you can kind of see the pattern of the waves. Now, the measure of angle 1 is equal to 2x plus 10. The measure of angle 2 is equal to 4y minus 30, and I have 70 degrees right here. We want to find x and y. So to get started, I know that the measure, well, let's go ahead and look at the angle relationship between these two. Well, angle 2 in 70 degrees, these are corresponding angles, so they are congruent. So I can start off by saying 4y minus 30, which is measure of angle 2, is equal to 70 degrees. From here, I can just go ahead and solve. I get 4y equals 100. Therefore, y is equal to 25. So I already solved for y. Next, what's the relationship between angle 1 and 70 degrees? Well, they are same side interior angles. I'm ignoring this middle parallel line for now. And I notice that they are inside these outside parallel lines, right? They're inside here. And they're on the same side of my transversal, which means that they're supplementary. So 2x plus 10, which is measure of angle 1, plus 70 is equal to 180 degrees. This will give me 2x plus 80 equals 180. 2x equals 100. Therefore, x is equal to 50. So those are the measures of x and y based upon that figure. Next, given P is parallel to Q, and measure of angle 1 is equal to 6x plus y minus 4. Measure of angle 2 is equal to x minus 9y plus 1. And the measure of angle 3 is equal to 11x plus 2. Find x, the measure of angle 1, the measure of angle 2, and the measure of angle 3. So to get started on this, there is quite a bit of work that we need to do. But the first thing I'm going to do is I'm going to see this angle relationship between angle 1 and angle 2. And I notice that they're alternate interior angles, so those are congruent. So I can automatically say 6x plus y minus 4 is equal to x minus 9y plus 1. Now, if I go ahead and I solve this on both sides to get started, I can subtract a y from both sides, right? And I can subtract an x from both sides. And this will give me 5x minus 4 equals negative 10y plus 1. Now, at this point, I'm going to go ahead and get x all by itself. So I'm going to add 4 and divide by 5. So this will give me 5x equals negative 10y plus 5. I divide both sides by 5. I get x is equal to negative 2y plus 1. Now from here, I now know what x is. I should be able to substitute in and solve for y. So looking at the relationship between angle 2 and angle 3, well, these are supplementary angles. They're a linear pair, so I can say that angle 2 plus angle 3 equals 180 degrees. If that's the case, angle 2 is x minus 9y plus 1. Angle 3 is 11x plus 2. And the sum of those equals 180 degrees. This will give me, combining like terms, 12x minus 9y equals 177. So from here, I'm going to go ahead and bring this equation over. 12x minus 9y equals 177. And I'm going to go ahead and substitute negative 2y plus 1 in for x. So I now have 12 times negative 2y plus 1 minus 9y equals 177. This will give me negative 24y plus 12 minus 9y equals 177. Negative 31y equals 165. Dividing both sides by negative 31, we get y is equal to negative 5. Now that I know what y is, I'm going to go ahead and plug it back in to find x. So to find x, we have x is equal to negative 2 times negative 5 plus 1. That'll give me 11. So x is equal to 11. So I now know that x is equal to 11. I now know that y is equal to negative 5. I can plug back in, find angle 1, find angle 2, and find angle 3. So again, here's all the work that we just did to find x and y. Now I'm going to plug them back into these equations. So the measure of angle 1 is 6 times 11 plus negative 5 minus 4. Gives me 66 minus 9, which is equal to 57 degrees. Now again, angle 1 and angle 2 are congruent. So angle 2 is also equal to 57 degrees. I don't need to do any more work on that. And I also know angle 2 and angle 3 are supplementary. So angle 2 plus angle 3 equals 180. Subtract 57 from 180 and we get measure of angle 3 equals 123 degrees. And those are all of our answers. X is 11, Y is -5, measure of angle 1 is 57, measure of angle 2 is 57, measure of angle 3 is 123. And those are all of our answers. All right, next up, go ahead and try this one out on your own. S is parallel to T. Measure of angle 1 is 3x minus 6. Measure of angle 2 is 5x plus 2y. And measure of angle 3 is x plus y plus 6. Find x, y, angle 1, angle 2, and angle 3. I'll post the answer so that you can check very shortly. All right, similar to the last one. First off, angle 1 and angle 2 are congruent because they are alternate interior angles. Angle 3 is supplementary to angle 2, which means that's also supplementary to angle 1 because those form a linear pair. So we can start off by saying measure of angle 1, which is 3x minus 6, is equal to the measure of angle 2, 5x plus 2y. That will give me, once I solve everything, negative 2x minus 6 equals 2y. Y is equal to negative x minus 3. As for our other equation, we know angle 2 and angle 3 are supplementary, so 5x plus 2y plus x plus y plus 6 equals 180 degrees. This will give us 6x plus 3y equals 174. So I'll go ahead and bring that over. 6x plus 3y equals 174. From here, I'm going to go ahead and substitute what y is equal to into our other equation for y. So I now have 6x plus 3 times negative x minus 3 equals 174. Whoops, let me just go ahead and show you guys the answer. So we are right down here right now. Once we go ahead and we solve for x, because we plugged in for y, so we can solve for x, we end up with x is equal to 61. So again, this is just me plugging in right here, and then solving, I get x equals 61. I then take that 61, and I can plug it back in for either answer, and we get y is equal to negative 64. I plug it in right up here, negative 61 minus 3 is negative 64. Now that I have x and y, I can plug it back into each angle and find the measure. So, plugging in for the measure of angle 1, we have 3x minus 6. Well, that will give me 3 times 61 minus 6, which is 183 minus 6, giving us 177 degrees. Angle 1 and angle 2 are congruent because they're alternate interior angles, so angle 2 is also 177 degrees. Lastly, angle 2 and angle 3 are supplementary. If angle 2 is 177 degrees, means angle 3 will be equal to 3 degrees. All right, with that being said, we have now finished up today's lesson. Your homework is on Schoology. It is due at Sunday at 11:59. If you guys have any questions for me, please let me know. But thank you guys so much for watching, and have a great rest of your day.